you all on this wonderful platform that is BYJU'S Exam Prep. And guys, this is the session where we are discussing about the simple mechanism. This is the series where we were discussing about theory of machines, most important topic, the very first chapter, simple mechanism. And today we are going to discuss about the inversions of double slider crank mechanism. In yesterday's class, we have seen the inversions of single slider crank mechanism, that is crank and slotted lever mechanism. And guys, in that we have understood how it is going to help in shaper and planar machine. And then also we have seen, my dear, simple 4-bar mechanism, degree of freedom concept one day before. And today we are going to complete this simple mechanism topic by discussing the double slider crank mechanism. So guys, when we are talking about double slider crank mechanism, it is very important part, because if you see the recent 3 years, questions have been there from this. Like questions are coming from that is elliptical tremel, questions are also coming from Oldham's coupling. Yes, Abhimanyu Singh, Midun and Arshada, welcome to this session, guys. And guys, we are starting the session now. I feel you guys are getting it. Please tell me my audio video clear or not. So this is some detail about me. I'm having around 10+ years of experience, and the topic of today is related to theory of machines. And guys, now I would be telling you about concept capsules. As you know, every Tuesday and Saturday we are going to have a concept capsule premiere for you at 9 AM in the morning, and there we are going to discuss some very important concepts which are coming in exams as well as they are being asked in interviews. So it is definitely going to be very helpful series, and the time for that is 9 AM. Tomorrow is Tuesday, so tomorrow's second episode of concept capsule will be coming for mechanical peoples, and tomorrow's topic is thermodynamic cycles and mechanical cycle. So you can join sharp 9 AM tomorrow to attend this second episode of concept capsule series. Okay, and that is a very important topic, thermodynamic cycles versus mechanical cycles. Like we had previously centrifugal forces versus centripetal forces. So guys, now we are starting with double slider crank chain. So my dear, I would like to tell you that when the name of the chapter is simple mechanism, I told you, when a mechanism came for the first time in this universe, we have given the name to that mechanism as simple mechanism. So this simple mechanism was having 4 links. It was the first type of mechanism. So my dear, with 4 links we have studied. Total there are 3 configurations. The first configuration was simple 4-bar. And when we were having simple 4-bar, we were having 4 links joined with 4 turning pairs. So this configuration is simple 4-bar, where we are saying these are 4 links and they are attached with 4 turning pairs. So my dear, the configuration will be defined as number of links as 4, number of turning pairs as 4. So when we have seen the second configuration, it is single slider crank mechanism. So my dear, it is nothing but the IC engine configuration or EC engine configuration, where we were having a cylinder like this, we were having a piston like this, and my dear, at the same time we were having a connecting rod and crank. So my dear, this was the second very important configuration. Now my dear, we are entering into the third configuration, that is nothing but double slider crank chain. So if you see, one turning pair here is converted into sliding pair, because if this is link 1, this is link 2, this is link 3, and this is link 4, and this is link 1. So this is a turning pair, this is a turning pair, this is a turning pair, but between 1 and 4 is a sliding pair. So I will say the configuration is 4 links, 3 turning pair and 1 sliding pair. So when 1 turning pair is converted into sliding pair, we reach to this configuration. Similarly, my dear, when 2 turning pairs are converted to sliding pair, we will reach to the third configuration, which is nothing but double slider crank mechanism. So we are writing it chain because none of the link is kept fixed till now. So guys, just like and share the session so that other student can also join. So my dear, first of all, we are having a elliptical plate. First of all, we are having an elliptical plate like this. So my dear, when we are talking about this elliptical plate, this is link number 1. Okay, and my dear, then we have a slider like this. This is slider. Then we have a slider like this. Then we have another slider like this. So my dear, in this way we have 2 sliders. And my dear, the link which is joining these 2 sliders is nothing but this. And this link is said to be coupler or coupling rod. If you see this configuration, you can see one link is this, second link is slider, third link is slider, and fourth link is this. So my dear, total number of links here are also 4. And if you will try to see the type of pairs, my dear, then you can see that with slotted plate and this slider is joined with the sliding pair, and this is one turning pair, this is another turning pair. So you will be saying there are 2 turning pairs and there are 2 sliding pairs. So my dear, 2 turning and 2 sliding pair, this is the configuration of this double slider crank chain. And my dear, when we are saying double slider crank chain, you can say there are 2 sliders. And my dear, if you see total number of links are 4. You know, when we are having a kinematic chain and we want to make a mechanism for that, we need to fix a link of that. So when I want mechanism from this kinematic chain, I need to fix a link of the chain. And when I am going to fix a link of the chain, my dear, for that I have 4 options. So if I ask you what are the maximum number of inversion possible, if I ask you what are the maximum number of inversions possible, what will be your answer? Maximum number of inversions possible. If I ask you the maximum number of inversions possible for this double slider crank chain, what would be your answer, guys? कितने मैकेनिज्म मैक्सिमम बन सकते हैं, कितनी इन्वर्जन मैक्सिमम हो सकती है? हाउ मेनी मैक्सिमम इन्वर्जन्स कैन बी देयर? यस गाइस, नंबर ऑफ लिंक्स आर 4. This data is with you. Yes, Midun, Abhimanyu, Harshada, very good. So guys, you are saying the answer is 4. Yes, maximum possibility is 4. In simple 4-bar mechanism also possibility was 4. Single slider also possibility was 4. But my dear, you have seen in the previous classes, for this we were getting actually 3 inversions. Because we were getting same relative motion for 2 mechanism. But if you will be using this, here you will be getting 4 inversion. Here there is, every time you will get different relative motion. But my dear, when we are having double slider, here also actually we will be getting only 3 inversions. Because when we will be fixing one slider or second slider, we will be getting the same relative motion. Because of that, once again, one inversion would be lesser in this case also. So my dear, what are the various inversion you will be getting? We will see one by one in detail. When slotted bar is kept fixed, you will be getting elliptical tremor. When any of the slider, like it is written, any of the slider is fixed. So there are 2 slider, though 2 possibilities are there. So when you will be fixing one slider or you will be fixing second slider, for both the cases, we will be getting Scotch yoke mechanism. And if you are going to fix the coupler means the link joining 2 sliders, this will give you Oldham's coupling. So now one by one we will be talking about all the 3 mechanisms and we will see detail of that. And not only that, we are going to solve problems also. So be ready guys, we are starting it. Yes. So my dear, the very first thing is when slotted plate is kept fixed. So my dear, when slotted plate is kept fixed, it will be looking like this. And my dear, what is going to happen if you want to see this time? As this slotted plate is fixed, slotted plate cannot move anywhere else. It will remain this only. So my dear, now what kind of motions are expected? When you will try to push the slider in downward direction, this slider will start moving in this direction. This would be the path followed by the slider. When slider would be coming down, this slider initially will be going away and then will be coming back. So my dear, this is going to be the path of this slider. This is going to be the path of this slider. So my dear, first of all, I want to show you the animation that how this mechanism is working. Then we will prove why the name given to this is elliptical tremor. So let us see first of all the animation for that. This is how you can see one slider is coming like this in this path, other is moving in this path. Okay, so you can see how the motions are going on. Okay, and these two red color dots, they are showing the presence of two slider. So my dear, now let us see why it is called as elliptical tremel. You can see the path travel. If you are going to take the path travel of any point present on the coupler, it seems to be an ellipse. So my dear, this path seems to be an ellipse. This is you have seen in the animation. Now we are going to derive it that yes, the locus of any point on this coupler is going to be an ellipse. Let us derive it, guys. So my dear, for deriving purpose, I am considering two sliders on x and y axis. Let us say one slider is present at this position, other slider is present at this position, and this is I am saying A, this is I am saying B, and we are joining these two. This is the coupler. So my dear, you want to see the locus of any point present on the coupler. Let us say P is the point present, x comma y are the coordinates. So my dear, this is nothing but x, this is nothing but y. We will be giving name to this. This is, let us say it is Q, it is let us say R. So my dear, now if this angle is going to be theta, no doubt about that this angle will also be theta. So my dear, now we will be taking two triangles. Yes. Okay dear, you can call it like that. Okay. So now we are talking about, yes, good evening Prakash. So now we are moving further, guys. So when we are talking about this point P, so you take triangle APQ. Taking this triangle APQ, we can write the expression for cos theta. Cos theta, when you will be writing it, is base upon hypotenuse. It is x upon AP. So my dear, when you will be taking the second triangle, that second triangle, no Prakash, it is not first class actually. Actually in this class, we are going to see the double slider crank mechanism. Already 5 classes are being over for this. Okay. So now we are talking about the second triangle, but don't worry, this topic you will be getting very easily for that. Okay. So the triangle PBR. For this triangle, if you will be writing the sine theta, so you can write sine theta as y upon BP. My dear, this is equation number 1. This is equation number 2. You have studied the coordinate geometry, and in coordinate geometry, you are always writing this equation: sine square theta plus cos square theta is equals to 1. So my dear, you will be able to write y square upon BP square plus x square upon AP square is equals to 1. So my dear, your equation is going to be like this. It is x square upon AP square plus y square upon BP square is equals to 1. If you see this equation, this is an equation of ellipse. This is an equation of ellipse provided AP is not equals to BP. And my dear, if AP is given equals to BP, in that case this will become circle. But my dear, AP will become equals to BP only in one condition, if P becomes midpoint of A and B, of AB, you can say. So if P is midpoint of AB, then you can write it to be a circle. So my dear, on this link AB there are infinite points. So out of infinite points, we are getting circle for one point, and for all other points we are getting ellipse. So my dear, for all infinite points we are getting ellipse, because infinite minus 1 is again infinite. So as majority of the time we are getting ellipse, that's why the name of this mechanism was given as elliptical tremel. If we would be getting circle, in most of the time we may be calling it as circular tremel, but we are saying elliptical tremel because for infinite number of times, only except midpoint, every time we are going to get the ellipse. So my dear, this is said to be the elliptical tremel. And my dear, when we are talking about AP and BP, so AP and BP are said to be semi-major, and semi-minor axis. Semi-major and semi-minor axis. Why we are saying semi-minor and semi-major axis? Because ellipse equation is x square upon a square, y square upon b square is equals to 1. So here A and B are Nothing but semi-major and semi-minor axis. Okay guys, so the point is, when we have an ellipse to be plotted like this, then this distance is 2a, the total major axis. This distance is 2b, the total minor axis. So if somebody asks you major and minor axis, you need to multiply it with 2, and 2AP and 2BP would be your major and minor axis. One by one you can calculate in this way. Is it clear for everyone? And I would like to say machines are made up of mechanisms only, because we have seen that in the previous lectures, that from link to pair, pair to chain, chain to mechanism, mechanism to machine. Okay, so that's why in short we say theory of machines, because machines are coming from mechanisms only. So guys, this is something we have discussed. Okay, so this is the animation which can show you how the working of elliptical tremel is going to happen. So how you can plot ellipse. This can show you very easily that when you are talking about AB, any extension of AB will also give you the ellipse. So it simply means that if you keep your pencil at any point on this line throughout, even if you put the pencil here, then also, my dear, this point will also be creating an ellipse only, and AP and BP would be the semi-major and semi-minor axes for the sure. So this is how we can use this elliptical tremel. I feel everybody got it. Okay, so my dear, with this one inversion we have completed. So elliptical tremel is going to be used to plot ellipse. This is available in your labs of kinematics of machine, dynamics of machines. You will get it. And my dear, this is used in civil engineering application also, where they want to plot such kind of geometry. Now my dear, we are entering into the second inversion, because we have seen the first inversion. The second inversion is if we are going to fix a slider. So one by one I will show you what is the effect of fixing one by one of the link. So this time, my dear, elliptical plate is free to move, because at one time we fix only one link. So this time slider is kept fixed. So my dear, you can feel if I will be fixing this slider. Just imagine this slider is fixed. So if this is fixed, this slider cannot move from here. But my dear, at the same time, when the slider is kept fixed, you must be aware of one thing, that this is a turning pair. So this link coupler is corrected in turning pair. So definitely, without having a linear motion, this can have the rotation about this point. Very easily that motion is possible. So if that motion is possible, my dear, this is a condition. You know that if this is going to rotate like this after certain time, this point after a rotation of theta must be reaching at this point. And if this point would be reaching to this point, there is no doubt, because this slider is free to move, this slider will have a tendency to reach at this position. But this slider is inside the slotted plate. So my dear, that slotted plate has to move if this slider is going to move. So my dear, the slotted plate will also travel, because you can see this is free to move. So as it is free to move, it is going to travel a distance. So my dear, now the new position of this elliptical plate is going to be like this. This is the new position of this. You can see, you can feel it. This is the new position. Okay, so this is the new position. And with this new position, you can see slotted plate have moved to some distance in this direction. And my dear, when it will keep on rotating, this motion will keep on like this, and after some time it will be coming back. But you can feel, because of slider is present in the elliptical plate will be going in the straight path. So it will be going like this and that. And my dear, this is nothing but to and fro motion about some mean position, and that is why such kind of motions we are giving the name of simple harmonic motion. So my dear, that's why here as an output we are producing simple harmonic motion. So the previous inversion was giving us ellipse, this inversion is giving us simple harmonic motion. And my dear, when we are getting simple harmonic motion, this kind of inversion is also shown in some other format in many of the textbook. it is shown like this, like this, like this. So my dear, the same configuration, because this slider is fixed, it is acting like a turning pair. So we have made the same 1, 2, 3 and 4 and 1. So this is also a notation for this mechanism. And my dear, this mechanism was given by big mathematicians, Scotch, Yolk. So it is named after them, Scotch, Yolk mechanism. They were mathematicians, and my dear, they have given this wonderful mechanism. So guys, you have seen already elliptical tremel, you have seen Scotch, Yolk mechanism. So guys, like and share the session. We are coming to the Oldham coupling, the most difficult one to understand, and then we will be solving some problems also. And after solving the problems, my dear, then I will be telling you that as we have done a SOM marathon on 1st of May, we would be planning for the similar for theory of machines. So I will be giving you the time for that, and I will be announcing about that. That is going to be really helpful to you, those who are studying theory of machine. This is the animation for Scotch Yolk mechanism. You can see motion is going like this, simple harmonic motion. Okay guys, now my dear, we will try to see what will happen. Now we will try to see what will happen if we are going to fix another slider. So let me show you that. If you are going to fix slider number 2, if we would have fixed this slider, then what will happen? If we would have fixed this slider, you will be giving rotation to this like this. And when this would be rotating, my dear, this time this part would be going to SHM like this. So my dear, when this slider is kept fixed, SHM is going like this. When this slider is kept fixed, SHM is going like this. So only the axis or the line of stroke of SHM is going to change. Nothing else is going to change. So my dear, only this change is going to happen when we are going for fixing another slider. So my dear, it is simple. If you feel that it is just a rotation by 90 degree, previously we were having SHM like this, now we are having SHM like this. It is just a rotation of 90 degree for the line of stroke, for the line of motion of slider. And when such a change is going to happen, my dear, we will not be calling it as a different mechanism, because it is not going to be a different relative motion. Until and unless relative motion remains same, we will call it as the same inversion only. So it is not at all a different inversion, but a same inversion only. So this is, my dear, Scotch Yolk mechanism. So my dear, this is the animation for Scotch Yolk mechanism. Once again, you can see this is very much similar to the diagram I have plotted for you. This is very much similar to the diagram I have plotted for you, Scotch Yolk mechanism. Okay, I have made the same diagram. So my dear, now we are moving to the third, that is Oldham's coupling. This is the last inversion, because one inversion vanishes. Now we are talking about the last inversion. So my dear, when we are talking about this time connecting rod is going to be fixed. Connecting rod is nothing but the coupler. So my dear, this time if you can feel it, we are going to fix this coupling rod. This is the coupler, and we are keeping this coupler to be fixed. So my dear, when this coupler is going to be fixed, when this coupler is going to be fixed, my dear, then this sliders cannot translate, because if this link is fixed, the slider joined to them are also fixed. They can also not move. But you forget, my dear, here is a turning pair. They cannot translate, but they can rotate at their own position. So let us say I am just attaching a shaft onto this slider, and previously this slider was present like this, but I have just given a rotation to the shaft. So when this slider is attached with the shaft, when I will be giving rotation to the shaft, this slider is also going to rotate. So my dear, this slider will be rotating like this. This slider cannot rotate without the motion of slotted plate. Slotted plate will also be rotating and coming like this. But slotted plate is like this. So if it will be rotating from here, it has to rotate from here because this complete is a one body only. So my dear, here also the similar rotation will happen. And my dear, if here also the similar rotation will happen, then if we are going to join another shaft with this slider on the other side, that will also get rotated. So in that way, you are giving power from this shaft to that shaft. So you are transferring the power from one shaft to another. You know, my dear, the things which are going to help us in transferring the motion or power from one shaft to another, they are given the name of couplings. So my dear, they are given the name of couplings. So coupling is nothing which joins two shafts or which transfer the power from one shaft to another. My dear, if you have two shafts whose axes are collinear, if there is a shaft whose axis is this, another shaft with this axis, so when their axes are collinear, my dear, then the coupling with which they will be joined is said to be flange coupling. So flange coupling is used to join the shaft which are having coaxial, you can say, which are. And my dear, if the axis of two shafts are making some angle, then my dear, you need to go for universal joint. U-joint to join them. And my dear, if two shafts are having some lateral misalignment, what is lateral misalignment? Like if one shaft is like this, another shaft is like this. So they are laterally misaligned because their longitudinal axes are having some lateral displacement, or you can say gap or offset. So that is said to be lateral misalignment. So my dear, if lateral misalignment is there, we would be using Oldham's coupling. Because here one shaft is this, second shaft is this. Both the axes are laterally misaligned. Is it clear, guys? So my dear, when laterally misaligned shafts would be there, we would be having the coupling name as Oldham's coupling. So you are going to give rotation at input, you are going to get rotation at output. So this is how the things are going to happen, guys. So my dear, this is the Oldham couplings working. You can feel both the shafts are, yes, they are having some misalignment. Some offset is there. And my dear, this body, if you can feel it, this is said to be Oldham coupling. And my dear, you can see here both the shafts are rotating about different axes of rotation. So when both the shafts are rotating about different axes of rotation, my dear, then Oldham coupling, which is joined with both the shaft, it has to partially slide also, and that you can feel it, that this Oldham coupling is also sliding along with the rotation. That is showing the sliding motion, you can feel here. Okay, yes. And if you want to feel the Oldham coupling is a circular disc like this, where you are having one slot here, other slot here. Okay, in that way Oldham coupling is going to run. So my dear, this was the third inversion, and we have seen all the inversions. So my dear, if you write all the inversions one by one, first one was elliptical tremel. Elliptical tremel was used to make the ellipse. Second was Scotch yoke mechanism. Scotch yoke mechanism. That was used for SHM. Third one is Oldham's coupling, which is used to join angularly misaligned shaft. Angularly misaligned shaft. Is it clear, guys, for everyone? Please tell me that. Is it clear for everyone? Yes, very good. So guys, this is how we are going to see. So one more figure for Oldham coupling is this. This is giving us more clear idea. So guys, now we are going to see some questions. We will be starting from the last question, and I will be giving you some extra concepts of mechanical advantage also. So if you see, this is the question. Okay, Better let us see from 11th, elliptical tremel. In an elliptical tremel, the length of link connected the two sliders is 100 mm. So my dear, first of all, if you see this question, you just make a figure for elliptical tremel. We have two sliders like this, AB. So my dear, you can see in an elliptical tremel, the length of the link connected the two slider is 100 mm. So AB is given as 100 mm. Then he is saying the tracing pen is placed on 150 mm extension of the link. Placed on 150 mm extension of the link, the major and minor axis of the ellipse traced by the mechanism. So my dear, this is 100 mm and we are putting the mass 150 mm away in the extension. This is 150. This is P. So you need to answer about major and minor axis. Anybody? Okay, very good, Abhimanyu. You have asked a very good question. I would like to say the maximum offset permissible is 7 to 9 mm. Okay, actually that is the general value. We can have slightly more than that also, but we are keeping it less because when we will be having more offsets, then my dear, chances of, you can say, losses would be more. And also I would like to say, as old time coupling was sliding, so if somebody sometime is asked that what is the velocity of sliding, this is d into omega. Velocity of sliding is given as d into omega. Here d is the offset. In general, it is, I am saying, it may be slightly more also, but power loss would be more in that case. Okay, so I feel some of you have answered it C. Midun is saying B. Okay, what about others? So I already told you, wherever the point P goes, it doesn't matter. If he is asking you about major and minor axis, you will simply answer 2 times AP and 2 times BP. Can you tell me what is AP? It is 250. So 250 ka 2 time is 500. BP is 150. 150 ka 2 time is 300. So the answer is C, no doubt. Answer is straight away C. Is it clear, guys, for everyone? Yes. So guys, let us move further. This is the next question. A crank and slotted lever quick return motion mechanism. I told you we are going to discuss some other questions, extra questions. We are going to do that as per the promise. And we will also see now the concept of mechanical advantage within 5 minutes. In a crank and slotted lever quick return motion mechanism, the distance between the fixed centers. I would like to say the distance between fixed center is nothing but L. It is 160 mm. Crank is 80 mm. And the ratio of time taken by cutting to return stroke. Okay, R and L are given to you. R and L are given to you. Yes. R and L are given to you. You need to answer, guys, about beta by alpha, TF by TR. I already told you the first step would be cos alpha by 2. Always the question started by cos alpha by 2 is R by L. This will give you alpha. Then you know alpha plus beta is 360 degree. This will give you beta. Once you know both alpha and beta, apply this to find out the ratio. I feel everybody will be giving the right answer. So, okay, Harshada is saying D. Amab is saying B. Bhavya 2, Midun D. Okay. So majority क्या सभी एक ही आंसर कर रहे हो? All of you are saying the answer is going to be 2. Yes, you can very easily find out. Cos alpha by 2 is 80 by 160. This will give you alpha 120, beta 240. Answer will be 2. Very good, guys. Very good. So if you see the next question, guys, ABCD is a mechanism with link length AB is 200, BC is 300, CD 400, DA 350. Which one of the following link should be fixed for the resulting mechanism to be a double crank? So this is from Gradeup law. This question is from Gradeup law. Yes guys, what do you say about this? Okay, Amab, don't worry. So let us have the next session related to transmission angle and problems related to that. But as tomorrow is Tuesday, tomorrow there will be no class from my side. Tuesday, you know, is a week off. So we will have this class, okay, and that I will be telling you in the Telegram. Maybe on Wednesday we will plan it. Okay. Bhavya is saying answer as AB. Okay. Anybody else? So it is mentioned that AB is 200 mm. BC is 300 mm. CD is 400 mm. DA is 350 mm. Which one of the following should be fixed? You know that the S plus L less than equals to P plus Q. So S is 200, this is 400. So 600 less than 650. So my dear, you will be fixing shortest link now. Then you will be getting double crank. Very good guys. So next question. Yes. A man is climbing up a ladder. We are having a ladder like this. Okay. This is a ladder. A man is climbing up a ladder against a vertical wall. When he was exactly halfway up, the ladder starts slipping the path traced by the man. This you can feel also. This is the feeling of first inversion. Yes, anybody else? What is your answer? Parabola, hyperbola, ellipse or circle? Yes, Bhavya is saying circle, Harshada is circle, Abhimanyu is saying circle, and yes, you know circle is correct. Because I told you only midpoint is going to plot the circle in elliptical tremble, and you know it is in case of elliptical tremble only. Okay, so this is how the questions are framed in engineering services. In a crank and slotted lever quick return motion mechanism, the distance between fixed centers L is 200 mm. The length of the driving crank and the slotted bar are 100. Okay, length of the R is 100. Slotted bar. You need to find out the stroke length. I am giving you the formula 2ls R upon L. This is the stroke length. Apply the formula, get the answer, give the answer. Bhavya is saying the answer to be C. This is a question from engineering services. Objective. Yes. Very good SK blocks. So this time also majority of students are giving the answer as C. Okay, let us see. This is going to be 2 times LS. So length of slotted bar. Length of slotted bar is 500 into 100 by 200. Okay, so the answer is, you can see without calci you can do this, because in ESC calci is not allowed. Fine guys. Okay, which of the following is the inversion of single slider crank mechanism? Yes, let us see. What about this? Bhavya, SK, Yes, Arnab, Midun, Harshada. And guys, like and share the session. Okay, Bhavya is saying D. Midhur is saying D. The answer is D. Because my dear Whitworth, you are getting by fixing the crank. Hand pump we are getting by fixing the slider. Oscillating cylinder engine we are getting by fixing the connecting rod. Very good. So everything we have seen already. Okay. Next question. In a crank and slotted lever quick return motion mechanism, the distance between the fixed centers 150. Length of driving crank 75 mm. It is very easy question. I feel anybody can answer it. Without solving, you can answer it. This is also a shortcut. When you get R like this, beta by alpha is 2, alpha 120, beta 240. It is very simple, and this case have been asked many times. So answer is straight away B. There is no problem in that. Okay, this is the last question for today. Solve it properly. It may be a MSQ also. ये MSQ भी हो सकता है, so solve it properly. Very good, Prakash. So guys, please tell me, everybody want transmission angle or not? If you want, let's have a session where I will be talking about transmission angle, toggle mechanism. If you want, I'm ready to take. I know there is difficulty in that topic with many students, so we can have that session, don't worry. Yes. Great. So you see that figure shows the layout of quick return motion mechanism. The driving crank BC is 30 mm. Beta by alpha is 1.7. You know alpha plus beta is 360. So you can use these two equations and you can find out alpha and beta. Okay, so by using this you can find out alpha and beta, and you can see the length of working stroke is 120 mm. So stroke length is given as 120, which is 2 times ls r upon L. You can also write it as 2 times ls cos alpha by 2. You know alpha from this, put here. Stroke length is given to you, you can find out length of slotted bar. Arnab, actually if you are not getting the time for that, try to solve mathematics at the time of weekends, or you can also use your public holidays for the same, because this is how we can manage the time. Actually when we are college going, definitely it is not easy to go with 2-3 subjects parallelly. Okay, so my suggestion is use weekends for practice majorly, and also you can use the public holidays for the same. Okay, and sometime if in the college you get the time, because 75% attendance is there, use the rest 25% for your preparation. Harshada is saying B. Okay, can you tell me what you are getting ls from here? I want ls value also. Try to check. You may get B and C as correct. Okay, this cannot be correct because quick return ratio is always more than 1. So return stroke is faster. So time for return stroke is always lesser. So from B and C, how many are correct you need to check. Whether both B and C, only B or only C, you need to check and tell me. Yes, what do you say, guys? And kindly like the session, share the session. Yes. Anybody? Okay, it is coming 77. Approximately you can say. So B and C are going to be correct. It was a MSQ. Okay. Okay, you are getting 151. If you are getting around 75.74, I feel you have done some mistake. Bhavya, have you used that 2? If you will be using that 2, then you may get 75.74. I feel you have missed this 2. Bhavya. According to me, it should come B and C. Yes. Can you confirm it? Dear, you just write stroke length is given as 120. Okay. Center to center distance is 75. This is small l only. They have said that working stroke is 120 mm. Okay. So they are asking about small l. Okay. Then you can directly use cos alpha by 2 r by l. So what you are getting, small l. Is it correct? Small l is coming. Very good. So guys, B and C are the correct answers. This was MSQ. Okay guys. So with this we have seen double slider crank mechanism. Now we are left with only one topic, that is mechanical advantage. And in that we will be discussing about transmission angle also. So okay, if we keep that session tomorrow, are you comfortable? If you are comfortable, we can plan it tomorrow also. Will it be fine if we keep it tomorrow? Okay, so you will be getting notified for that, don't worry, either tomorrow or day after tomorrow. So let's leave for the 2-day session and signing off with this. And guys, do like and share the session with your friends also. And also I would like to say that whenever I come with these kind of session, you must join if you have the time, because you will be getting some extra points for sure. And tomorrow 9 AM, second episode of concept capsule will be coming. The topic is thermodynamic cycle versus mechanical cycle. So my dear, if you want any special concept capsule on a particular topic, you can mention in those comment sections. We will be coming for that. Harshada, we will be covering chapter by chapter. We are going to complete first chapter first, and then in the upcoming sessions we will start the other chapter. Okay, but they will be in some gap, so that other subject also will be coming in between. Like now HMT will be coming. Okay, so we will be keep on changing, but every time I will not be taking the same chapter. Like this time we have taken simple mechanism. Next time I will be coming with velocity and acceleration analysis. Okay. So goodbye guys for this session once again. Thanks for joining. Thanks for your love and support.